Hello. In this video, we'll walk through how to solve a logarithmic equation. By the end of this lesson, you will be able to solve for a variable inside a logarithm, and most importantly, you'll learn how to check your solution for validity. Let's look at the equation we need to solve. The equation is log base 2 of the quantity x squared minus 1 equals 3. Our task is to find all real values of x that make this statement true. To solve this, our main strategy will be to convert the logarithmic equation into its equivalent exponential form. Before we do that, though, there's a critical step we must not forget: establishing the domain of our equation. Why is the domain so important? Well, a fundamental rule of logarithms is that we can only take the logarithm of a positive number. In other words, the argument inside the logarithm, which is x squared minus 1 in our case, must be greater than 0. Let's pause and solve this inequality. This will tell us which values of x are even allowed in our problem. The solutions we find for x later on must fall within this domain to be valid. So, remember, we must always check the domain first. So, we need to solve x squared minus 1 is greater than 0. We can add 1 to both sides to get x squared is greater than 1. Now, it's easy to make a mistake here and just take the square root, thinking it gives us our answer. But the inequality x squared is greater than 1 has two parts to its solution. First, we need to consider positive numbers. For a positive number squared to be greater than 1, the number itself must be greater than 1. So, x is greater than 1. Second, we need to consider negative numbers. This is where it gets tricky. Think of x equals negative 2. Negative 2 squared is positive 4, which is greater than 1. So, what's the pattern? For a negative number squared to be greater than 1, the number must be less than negative 1. This is because numbers like negative 0.5, when squared, become 0.25, which is not greater than 1. So, our domain, which is the set of all possible x values for this equation, is that x must be greater than 1 or x must be less than negative 1. This is a very important result, as it will be used to check our final answers. Now that we know the domain, we can focus on solving the equation itself. We'll start with our original equation again, log base 2 of x squared minus 1 equals 3. The most effective way to eliminate a logarithm is to convert the equation into its exponential form. This is based on the fundamental definition of a logarithm. Let's review that definition. If we have a logarithmic expression of the form log base b of a equals c, it is equivalent to the exponential expression b raised to the power of c equals a. Notice how the base of the logarithm, b, becomes the base of the exponent. The answer to the logarithm, c, becomes the exponent, and the argument of the logarithm, a, becomes the result. Let's apply this definition to our problem. We'll identify a, b, and c. In our equation, log base 2 of x squared minus 1 equals 3. The base b is 2. The argument a is the expression inside the parentheses, x squared minus 1. And the result, c, is 3. Now we substitute these values into our exponential form template, which is b to the c equals a. Plugging our values in, we get 2 raised to the power of 3 equals x squared minus 1. This is a much simpler algebraic equation to solve, and it shows the power of converting between logarithmic and exponential forms. Our next step is to calculate 2 to the power of 3. 2 cubed means 2 multiplied by itself 3 times. That is, 2 times 2 is 4, and 4 times 2 is 8. So, our equation simplifies to 8 equals x squared minus 1. We've successfully removed the logarithm and are now dealing with a simple quadratic equation. Now we need to solve the quadratic equation we derived. Let's recap what that equation is. We have 8 equals x squared minus 1. Our goal is to isolate x. The first step is to get the x squared term by itself. We can do this by adding 1 to both sides of the equation. If we add 1 to both sides, we get 8 plus 1 on the left and x squared minus 1 plus 1 on the right. This simplifies to 9 equals x squared. Now we need to find the value of x that, when squared, equals 9. To do this, we take the square root of both sides. This is another crucial point where students can sometimes make a mistake. When solving for x in an equation like x squared equals a number, you must remember to account for both the positive and negative roots. So, the square root of 9 is not just 3, it's positive 3 and negative 3. We write this as x equals plus or minus 3. So we have two potential solutions for our equation. X equals 3 and x equals -3. However, we're not done yet. Do you remember that domain check we performed at the very beginning? Now is the time to use it. Our domain was x is greater than 1 or x is less than -1. Let's test our two solutions against this requirement. First, let's check x equals 3. Is 3 greater than 1? Yes, it is. This means that x equals 3 is a valid solution. Now, let's check our second potential solution. X equals -3. Is -3 less than -1? Yes, it is. This also falls within our domain. Therefore, x equals -3 is also a valid solution. Because both solutions we found are within the domain of the original logarithmic equation, they are both part of our final answer. It is always a good idea to substitute your answers back into the original equation to be extra sure, but the domain check is often sufficient. So, the real values of x that satisfy the equation log base 2 of x squared minus 1 equals 3 are x equals 3 and x equals -3. Let's quickly recap the entire process we followed. We started with the equation log base 2 of x squared minus 1 equals 3. The first and most crucial step was to determine the domain of the equation by setting the argument of the logarithm greater than 0. This gave us the condition that x must be greater than 1 or x must be less than -1. Any solution we found later would have to meet this criteria. Next, we solved the equation by converting it from logarithmic form to exponential form. This transformation eliminated the logarithm and resulted in the simple quadratic equation 2 cubed equals x squared minus 1, which simplified to 8 equals x squared minus 1. We then solved this quadratic equation using standard algebraic methods. After isolating x squared to get 9, we took the square root of both sides, remembering to include both the positive and negative results, giving us x equals plus or minus 3. Finally, we checked our solutions against the domain we found in the very first step. We verified that both x equals 3 and x equals -3 satisfied the domain condition. Since they both fit, both are valid solutions. Our final answer is that the real values of x that solve this equation are 3 and -3. In this video, you've learned how to solve logarithmic equations by converting them to exponential form, and critically, how to find the domain and check your solutions to avoid errors. Always remember that the argument of a logarithm must be positive. Thank you for watching.